So, mini unit quiz preview. Okay, when it asks me to write each expression in radical form, just a reminder here at the start, whenever we're going to radical form, reminders that my root, my little number, is always the little number that goes outside my radical. And then whether I have a number, a variable, both, whatever it happens to be, I find the exponent and I'm going to put it right in there with whatever that base value is. So here's how this works. When I look at number 1, okay, I go, okay, so I'm going to need a radical here. Whenever I'm doing these, the number on top is always my exponent. The number on the bottom is always my root. So when I go to write this, okay, if I see parentheses on my base, I'm going to keep using parentheses. Because what that means is that exponent goes to both of these. And then I just follow along. Exponent, okay, just like it is here. Root, just like it is there. And I'm done. Now, there is one little part to this that you could have a different answer written and it still would be okay. Because we assume when we're doing these that an exponent of 1 is there and that a root of 2 is there. So even if you just wrote this like this, that would be okay in this case. Bless you. So either one's fine, but most of the time it's not just going to be a half, so I'd actually have to put the numbers in. So if I were to do that on number 2, I'm going to do the first part of it here. Okay, I'll get my radical, I'll get my n. So what value is going to go right here? 8 does, because it's my exponent, and then my root just goes out there. I'm set. Again, keep it simple. And then the nice thing is when I get to the next part, I can kind of use this first part as my cheat sheet. Because I remember now, oh, when I'm going to exponential form, Harty just said right there that it's exponent over root. Now how convenient is this? Whatever's underneath, I'm going to put in parentheses, and I'll explain in a second here why that's critical and why I have to do that. So, okay, my exponent would be 1, I agree. It would. Because again, we just got done saying up above, if I don't see an exponent, we assume it's 1. If I don't see a root, I assume it's 2. So you're like, but there's no parentheses in there, why'd you do it? Okay, here's why. So don't necessarily write what I'm about to do, just kind of watch. If I wrote it this way instead, that 1/2 exponent's only going to the x. So like if I were to rewrite this in radical form, it would look like this. Well, that's not what that is. I don't want that. So whatever's underneath, make sure you use parentheses if you're going to the exponential form. Okay, it's just a safe thing to do. So then what would number 4 look like once I get my 3x in parentheses? 7 over 4. Yes. Exponent over root. Just like E comes before R in the alphabet, same thing when I'm looking at my fraction. And I'm set. You're like, okay, this isn't too bad so far. Okay, simplify. Now again, I suppose you could try to do this in your head. I'm not gonna, but you know, you got your own option on this. So simplify basically means as long as you can get this typed into the calculator, you're gonna be fine. Here's the only place that can get this messed up. Well, forget your caret, that would be a problem. But yes, you've got to remember with fractional exponents that you want parentheses. Because if you forget, oh, watch this craziness when I forget. Yeah. Okay. That's a really, really big number. You're like, how big is it? 2.38 with 13 zeros on the end to the right. So yeah, we're into like the millions, but we're like to the Powerball, type money here if we do it that way, but that's not the right answer. So we don't want this one. This first one was the correct way to go about it. And then I just do the same thing on the next one. Again, just remember, you're like, okay, feeling good. I'm gonna rock out this quiz. All right. Then we get to the part that's a little closer to our last quiz in some ways. We're going to use some exponent rules. And we've talked before about how there's 4 basic ones I need to remember. If I'm multiplying, I add the exponents. If it's power to power, like parentheses with an exponent, I times the exponents. If I'm dividing, I subtract the exponents, bigger minus larger. And if there's negative exponents, we flip them. So, I start looking at this. Number 7, what am I going to be doing to the exponents? Adding. Now, here's my issue. When you're adding fractions, you have to have a common denominator. So I can't just add across right now and call this 3 over 3 and call it good. It won't work. So, what would my common denominator be here? 2. Which means the 1/2 part is fine. But right, to get to the second part, okay, whatever I multiply 1 by to get to 2, which is 2, I got to do the same thing to the numerator. So 2 times 2 is 4. Then I can add the numerators together, but I leave the denominator alone. Okay, but when I'm adding, I have to have a common denominator. That's all there is to it, and I'm good there. So, when I move forward then to number 8, okay, what am I going to be doing to the exponents there? Distribute. I'm going to multiply. Now that's different. I don't have to have a common denominator here. So I'm going to have 2. I'm going to make it a fraction because multiplying fractions together is a little bit easier. And I'm going to multiply straight across, okay? Not cross multiplying. This is not a proportion. Straight across. So let's see here. I'd have 2 over 4. Exactly. Once I multiply straight across, if I can reduce the fraction, I need to. So 2 over 4 is 1/2. And 4 over 4 is 1. I can just leave it as y. Or if you want to call it y to the first, you could. But again, keep life simple. So move a little here. You're like, okay, these next ones don't look like exponents, but they don't need to be. So a couple quick questions. First, what's my number out here again? 2. Okay, so let's see. What's the square root of 36? 6. And remember, on these, it kind of goes back up to how this works. Exponent divided by root. What is 4 divided by 2? 2. I'm good. That's the answer. You're like, it didn't seem this easy when we were doing it the first time. It's the same thing, it's just you've seen it. So now, this gets a little more interesting. You're like, okay, I know my 128 has an exponent of 1. So it's exponent divided by root. So let's... No, I'm not. I could ask you what the cubed root of 128 is, but I don't know if you're going to know that off the top of your head. So we're going to try some things here. We're going to do a little thinking. We're still doing exponent divided by root. But we may have a couple of twists that we have to play with. You're like, uh-oh. So 128 to the 1/3. Okay, Harty, we're getting a decimal. So what's the deal here? Why am I getting, every other time I've done it with a number, I've gotten a whole number out. Why is this not working? Okay. So here's what we've got to do with this. I will not have a question on the quiz itself that does this, and in retrospect, I'm looking at this going, why did I do it on this one? Because I know what number I wanted to put in there, and I didn't do it. I meant, well, let's change on the fly. Let's make it the number that I meant for it to be. this was supposed to be 125. So let's make that adjustment. Because if it was 125, then everything is a little happier. Whoops, except, what did I forget? Oh yeah, the caret. Okay, that's kind of important. That's better. Okay. But that doesn't fix my problem with this end of the 4/3. Like, well, can I just leave it as end of the 4/3? Not exactly. If you remember back when we started doing these, we said, okay, if it doesn't go in evenly, let's think about it this way. How many whole times does 3 go into 4? Once. How many would I have left over? I'd have 1 left over. Now, if you don't remember how that is, we'll chat about that for just a second. Because we talked about old school division with this when we were looking at these. And basically what I'm going to do is, however many whole times it goes in, that's my exponent out here. If I have any left over, if I have a remainder, that remainder is what has to stay inside when I'm doing this. And then I can get to my answer. Okay, it won't happen on the number part, but it can happen on the variable part. So I can't just leave it as 4/3. I actually have to fix that up and break that down if I can. So, all right, let's see here. 11. Solve the equation. Remember to check for extraneous solutions or answers that don't work. What do I have to do first? Okay, we got to add the 5 because we got to get that radical isolated. So we add the 5 over. Okay. Keep talking to me. Okay, we're going to square it because we got to get rid of the square root, and that's the opposite, is to square it. So again, that just cancels the radical. Don't mess with what's underneath. But on the other side, it's not a radical. So what's 9 squared? 81. And now it's just a regular old Algebra 1 problem. So that 9's positive, so I can minus it out of there. And again, little details. Make sure you don't lose your negative on your 9b, because otherwise it'll kind of mess up your answer. Divide by -9. We get -8. Now again, don't make assumptions here. So here's maybe the way that I would look at it. If I have issues with doing like all this double negative and stuff like that, here's what I would be considering doing. I'd be like, okay, so now see, I don't even want to use the square root. And you're like, why not? Too many parentheses. So 9 minus 9 times -8. So what's the square root of 81? 9. 9 minus 5 is 4. Okay, check. I'm good. Okay, let me show you.
Because I just did it on my calculator and it worked. I just did the square root of 9 minus 9 times -8 minus 5, and I got 4.
Let's see. As long as I remember to close my parenthesis, I'm good. Okay? And that's the only thing I worry about. Sometimes a little detail, like forgetting to close a parenthesis, you do all the work right, and then you talk yourself out of it, which is why I just try to do it without having to take any of those chances. But as you can see, it works. So I'm never going to have an issue with that. Glad when you guys mention it. All right. 12.
Do you have to FOIL? No.
Do we in this one? No. Will we have to in one of them? Yes. Yeah.
I didn't need to get to that answer.
So when we get here, again, the square and the square root cancel. So no, I'm not having to do any foiling or boxing on this particular one. So now my whole job is just get all my k's on one side, get all my constants on the other, and be good. So somebody fire a first step at me, because there's no wrong place to go. Okay? Because I heard a couple different things there, and everything I heard was sensible. And then right, now I just got to isolate my k term. and quickly make sure that this is going to work. Okay, let's see. 2 times 5 is 10. 13 minus 10 is 3. 5 minus 2 is 3. Okay, that works.
Do you have any other clues that don't work?
Maybe.
Messy, yeah.
I'm just saying, it never hurts to take that. How long did that take me? I wish I'd have looked. Like 3 seconds to check. Okay? Doesn't hurt to take that 3 seconds.
It wasn't 3 seconds.
It wasn't. It was faster.
Like, you make look checking it so easy, but like, I just...
Well, but even like what you said before on the other one, if you literally just take it
Yeah,
and
but
plug in the exact problem
This one I got it.
and multiply then we better check this out. Okay. First step again, my radical's already isolated. I'm going to square both sides. Now this time we run into a different issue. Because over here on the right, radical cancels with squared. Okay. On the left, there's no radical there. So this is actually v squared. Bless you. And as we've said before, if there's a squared term, everything needs to go to that side. So this 20v needs to move to the v squared side. This negative 100, we need to do the opposite. Move it to the v squared side. So I end up with 0 on the right. And then I write my terms in order from greatest degree to least on the left. And then we bust out the algebra 2f word. We factor it. So let's see here. What do we know? What do we know? We know that we multiply to get 100, which means they're both positive or both negative. Both negative, because that's what the sign in the middle tells me. So two numbers that multiply to 100 and add up to 20. 10 and 10. And no, I don't have to do it twice because it's the exact same thing. So if v minus 10 equals 0, v equals 10, but I want to make sure. 20 times 10 is 200. Minus 100 is 100. And the square root of 100 is 10. Yes, it is. All right. You're like, Harty, these are all working. Maybe. Okay, 14. Oh, it's the dreaded number 14. Why is it dreaded? Yes. Because our other, that's like algebra 2, F word number 2, foil. Because, yeah, on the left side, we have a square root to cancel out our squared. They're inverses. They're opposites. However, on the right side, there's no radical. And I'll express this as strongly as I can again. I can't just distribute the squared. That's not x squared plus 49. It doesn't work. So, little side work is in order. Again, if you can FOIL and get there, that's fine. I've seen literally. Some of you are more visual though, so I would go visual. And when we go to the box, we're really just doing the foiling. We're multiplying what's on the edges of the box. So x times x is x squared. X times negative 7 is negative 7x. Negative 7 times x is again negative 7x. And negative times negative, again, you're multiplying, is positive 49. So let's see here. X squared. These do not cancel. Yeah, because it's like you're borrowing money. If I borrow $7 and I borrow 7 more, I'm not at even. I'm $14 in the hole. And now, similar to what we had on 13, everything needs to go to the x squared side. You got this. Add the 2x, subtract the 17. Okay, and if you've done these right, they will always factor out nice. So if for some reason you do this first part and you go to try to factor and you're like, this isn't factorable, something didn't go right before then. Because I'm not that crazy to put something unfactorable on here. Nice, okay. So 8 and 4, what about the signs that go with them? They're both negative. Because again, If I get a positive product, they're either both negative or both positive. So if I need a clue, there's my clue. So if I set those guys equal to 0, I get 8, and I get 4. What's that? Sure.
Maybe checking this.
Uh-huh.
Like, I just checked number 4. I could have done it wrong, like, before. I got 3 and -3, so wouldn't that not work then?
Correct.
Okay.
Right, because when you go to do these, you're right. When I stick this in, so like 2 times 8 is 16. 17 minus 16 is 1. So the square root of 1 is 1, and 8 minus 7 is 1. Okay, 8 works. Then I go to do 4. 2 times 4 is 8. 17 minus 8 is 9. The square root of 9 is... Wait, is that right? Yeah. Square root of 9 is 3. 4 minus 7 is -3. Are those the same?
No.
So 4 doesn't work. Okay, those are the types of little things you do have to watch for, especially if there's a couple of answers. You may get one that doesn't work. That's why we got to check them. Okay, so there'll be some of those. And then finally, we're going to do some graphing like we've been doing for the past couple of days. Now, as I mentioned yesterday, you need to have locked into your brain when we're looking at square root functions, like we are in 15. Oh, somebody's on top of this. Okay. 0, 1, 4, and 9, because they're my perfect squares. Oh. Okay, so anytime we have a square root, that's my base, okay, that I'm going to work with. When I have cubes, I have more options because cubes can go into the negatives. Now, I'm also going to mention what I mentioned when we were talking about this in class. If I forget, if I have a panic moment, if I go, oh my gosh, I don't remember the base, what do I do? You still have options, okay? All you've got to do, if it's your square root function, to give yourself a reminder, just type the square root of x in there and look at the chart. Okay? There's 0, 0. There's 1, 1. There's 4, 2. There's 9, 3. Okay? Your bases will be there, and then you got something to work with. If it's the cube, reminder, okay, cubed root can be put into the calculator by doing something to the 1/3. So, I just do x to the 1/3, and then again, if I look at my chart, there's the -1, there's the 0, there's the 1, and if I keep scrolling along, there's my -8, and I can get all those base numbers, okay? So if you got to memorize, that's better, makes it easier, but if you forget, there's still a way to get yourself some hope on that. I'll leave that up while we're doing this. Okay, so first question on 15. Shifts, what are they? Okay. Left 3 and up 3. That comes in handy when I'm trying to do my graphing on this. Because I notice there's no number in front, so it's just going to be my base points. So I'll go ahead, I'm going to plot my base points. A little off the chart here, but that's okay. And then I just take those 4 points and do the shifts. So up 3, left 3, up 3, left 3. Did I just do something silly? Nope, I didn't. Okay. Up 3, left 3. And connect the dots going to the right. Again, only an arrow on the right with my square roots. So now, domain and range have direct connections with my shifts. Remember, my domain is my x values. Okay, start at -3 and go to infinity. On a base graph, they both start at 0, but I went left 3, which went same with my domain. Okay, what about my range?
0 to.
Eh,
Wait.
did we move up or down? Eh,
Wait, you said we go from the bottom to the top.
yes.
Right.
Here's my start. I'm not starting at 0.
It's 3.
That's 3. Okay? Whenever we're doing these, just a reminder. Okay, hang on. If you have a left or a right shift, okay, that's going to affect your domain value. Here I went left 3. If I go left 3 on x, I go to negative. If I have an up or a down shift, that affects my range. I went up 3. When I go up on the y-axis, that's going to make my range go up. Because you're right, with our base graph, they do both start at 0. But if I have either of those, it makes my domain and my range move. So that's something where, again, and if you're not sure based on the shifts, just look at your graph. You know, where does it start? And I can look at the values that way. Okay. 16. Got a little adjustment to make here at the start. Because now I got a stretch number. So what we've done before, let me put this back up over here, is when we've looked at a stretch number, I go ahead, I draw my chart, but then whatever my y value is when I have a stretch, I multiply the y value by 2 in this case. So I'm multiplying all of my y's by 2 to create my new base points. So 0, 0, 1, 2, 4, 4, 9, 6. So you notice it kind of stretched out wider than my first one did. But once I get those drawn in, do I have any shifts that I have to deal with? What's that -2 going to do to my graph? Okay, we're going to go right 2. That's going to be funky for that one point, but that's okay. So each of my points, I'm going to go right 2, even though I'm kind of in the middle of my chart now. Draw my arrow in. Then I go, okay. Let's think about this for a second. Okay, domain is my x values from left to right. Where does my x value start? 2, because I went right 2. So my domain's 2 to infinity. What about my range? Did I move up or down at all? No. So my range stays at 0. And again, I can even see that on the graph if I want to look at it graphically. So you kind of see how these things kind of come together and how they make connections. And the only thing that's going to be different, our shifts are still going to work the same way down in these last two. But, let me get this back on. We're not going to see the difference in our domain and range, and we'll see why here in just a second. Okay. No stretches. What are my shifts going to be, though? Left 4, down 4. Because again, left, right, up, down. So, since I'm not shifting anything, my base points would stay the same. Kind of get that snake figure going through, kind of slithers through. And then, oh, this is going to be real crazy trying to graph. Okay. Left 4, good luck, Harty, on this one. Left 4 and down 4. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, And finally, 1, 2, 3, 4. 1, 2, 3, 4.
This is a weird, very weird.
Get my slither going here. Exactly. Here's the difference with cubes versus squares. I have arrows working on both ends with my cube, which means for my domain, even though I shifted, I really don't care because I'm going forever to the left and forever to the right. Okay, my range, I had a downshift, but I don't care because this is going down forever and up forever. Cubes are the easiest domain and range ever because we don't care if there's a shift. It's the same thing. And again, I can see that graphically if I didn't see it any other way. And finally, to wrap things up, I do have a stretch on 18. So, scooch this over a little more so we can see. Get my base points working. Get my y values working. And since I have a stretch number of 2 in front, all my y values are going to get multiplied by 2. So -4, -2, 0, 2, 4. So let's see here. -8, -4, -1, -2, 0, 0, 1, 2, 8, 4. So you can see how it kind of stretches a little more than it did on the last one. Okay, so we're going to go down 1 and left 4. So we're going to have another funky point working. Another off the chart here. So 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. But again, I get the easiest domain and range ever. If you are still having issues in any of these areas, again, go back and check this out later. Maybe you get an extra copy of this and try it out later and then kind of use the video to double check something, or you look at the key, or you do something with that to reinforce some of this stuff as you're going along. Or if you got some questions, pop in on me a couple minutes early tomorrow to kind of see how things are going. But let's make this a good one.